Hi everybody, this is SOA Safari in the Amazon. I'm Bryan Thompson. That previous talk was absolutely the perfect segue to this, and we couldn't have planned it better. So thank you to David. A lot of the concepts that he talks about, especially with being able to just wipe away machines and bring them back, are exactly what this talk is all about, only in production and in a rather complicated SOA sort of infrastructure. I've been a developer for about 12 years, well, since I was 12, which was more than that. Anyway, and along the way, we've built a lot of toys and crazy things. The team I'm on now is interesting because we find really weird ways to solve problems all the time, just like all of you do. But we seem to gravitate towards the ones that are extra crazy. So if anything strikes you as just weird, insane, whatever, just shout and call me out. Anyway, I'm the Vice President of Development for PaymentSpring. I'm also a Ruby minimalist, and I have very good reason why. And I'll get to that in a little bit. I love coding with the smallest amount of dependencies just to make it fast, testable, everything perfect. And I'm kind of at war with gems at the moment, but that's its own thing. In 2011, we saw Uncle Bob talk about the obvious architecture kind of concept. It was actually the clean architecture is what he calls it. And his talk's called The Lost Years, so go check that out. I watched it about 20 times. We talked about it for a full year and built a ton of prototypes that kind of led us to where we went with Obvious. We released it to the wild, and he gave us this little bit of feedback. So we're really excited to get that unofficial endorsement. And we got another sort of unofficial endorsement that I was even more excited about because this guy's just a jackass. You know, in reality, Obvious has nothing to do with Rails, and it was just fun to kind of see what his response would be. But they play well together. Obvious is just a really clean way to code, and you can put Rails on top of it, Sinatra. You know, you do a great API, all of these things, and it just works really well together. I have a lot of side projects. I just fall in love with ideas so quickly, and I can't stop. So I've got a dozen that are unfinished, but businesscard.io and heydummy.io are kind of my attempts to automate my life and kind of do some weird stuff. So I won't get into that, but if you want to check those out sometime, heydummy.io isn't up yet, but the basic concept for that is that I want to be able to curl my house and do things. And I want to have it remind me of things like simple stuff. I mean, I forget everything. I want to know when to mow the lawn, when to fertilize it. I want all of these things just to happen and tell me. I want it to tell me if the garage door has been up for 30 minutes. Anything like that. So anyway, other toys like Tabulator that basically watch your cron jobs and tell you if anything broke. Milksteak is a flat file CMS. Not a static generator, but it's actually a dynamic CMS that uses YAML files and it's queryable and sortable and does a lot of fun things. And again, more crazy stuff. And this talk is not quite an introduction to SOA because there's just so much in that topic alone. This is an example of our SOA. It's really crudely mocked up. We've got at the core our API router, and we've got all these services below it. These are supporting classes of servers that build all that stuff. Here's basically how everything talks together. It's a mess. And every service has a client, and any communication between the two is using the client and the service. They're all APIs within that whole mess. So coordinating that is a nightmare, but also updating that, and that's really where this is going. This isn't a talk about design patterns because there are so many ways to write a SOA. There's a really good thread right now on the Ruby Rogues mailing list that kind of talks about this, and it's, you know, do I just separate my controllers, or do I put my code over here? How do I actually make the SOA work? That's a design pattern discussion. Jump into that thread. It's actually really good, and it's going somewhere. This talk isn't all about Amazon. We love all of their tools. We use a ton of it. We jumped right into Dynamo as soon as it was released. Regretted it immediately, and then went back. But you know, we'll take whatever they're giving us and use it. But the principles really apply to all cloud providers and ways to do things. This talk is mainly about the problems we ran into when deploying our SOA and keeping it updated. As you saw, we have 7 services, and we have supporting servers, and all of this communication between. We'll launch a dozen, 2 dozen, however many it takes of each instance type. And now we've got just a huge mess of all kinds of servers doing all kinds of communication at all different levels of patches and such. So our main product is a payment gateway. It's got to be fast, reliable, scalable, fault tolerant, so we can't be in a single data center. And it's got to be PCI level 1 compliant, which that alone adds a crazy amount of complexity to just the way we can talk and do things. So our reasons for SOA primarily were that we wanted to be able to quickly write it in Ruby, because we love Ruby, but we wanted to be able to rewrite a service or a client or whatever in any language if it came to the point where we knew we needed to ship. So this gives us that. We wanted to be able to scale every service and every slice of this thing completely independently of any other part of the system. And PCI, one of the PCI requirements basically says you should segment your stuff. That's guidance, but everybody that we've talked to has broken that rule. So yeah, we needed all of these tools to work, and we needed full control of everything, including the networking, provisioning, and a lot of the cloud options that are enterprise don't really work for this, and I'll get into that a little bit too. We needed auto-scaling to be able to look at the performance of everything that's happening and just scale up servers, add more, throw them away, do whatever we need. We wanted something that was completely automated and hosted by somebody else. That's really hard to do in a PCI environment, and especially with our structure. And so we couldn't do any single data center solutions either, like the vBlock. The vBlock, I don't know if you guys know what this is, it's enterprise cloud, but it's really just two really expensive racks with an API that nobody can understand, and you don't actually have full control. So it's useless for us, but they just really wanted to sell it to us anyway. PCI requirement 6.1 basically ruined my life for a few months. It says, it's good guidance. All systems and all components and all libraries have to be completely up to date, basically at all times. This includes your gems, which is a big problem. Most of us don't code review every gem we install, especially between version updates of those gems. This is kind of really a problem, actually, because we have 7 service levels, and we have all of these things talking together and using all of this. PCI talks to us in a language from the past. I mean, it's saying your Windows server that's running everything, basically, needs to be updated. Okay, I'll run system update, I'm done. Well, that doesn't work at all in this environment, especially when you're splitting everything up. You're using Linux, you're using Ruby, and we're using gems. So this is why I'm kind of at war with gems. I have to watch every single gem update that comes out. Every gem is in scope. Anything we use to help manage those gems is in scope. Anything we use to help manage our SOA deployment scaling. So, as you can tell, I mean, this is really kind of a big problem. If you use something like Ubuntu, CentOS, whatever, you can subscribe to the services that will basically manage that for you. Ubuntu has Landscape, there's Cloud Passage, which basically does the file integrity and intrusion detection and all that stuff. Write Scale is really good for taking an app and letting you just scale it out and all of that. Hosted CI is awesome, and we really wanted to use that as well from all of the providers. We can't use any of that. We can't use any of it because Landscape charges per server, and we have hundreds of servers out there. It would cost a fortune. Our business would never work. Cloud Passage, they advertise, and I might be wrong about this at this point. This is a while back, but anyway. When we looked at it, Cloud Passage advertised two-factor authentication on the servers, which is totally what we need everywhere. We need two-factor everywhere. But their interface that you log into to manage all of this isn't two-factor. So that's a pretty clear problem for us. We couldn't use that. Write Scale, again, super expensive and crazy. Also, we couldn't just open up our entire deployment infrastructure, SSH keys, our certificates, everything that goes into encrypting credit cards, we can't just give them. So none of that worked. We had to come up with our own solutions. And if every gem and every update of every gem is in scope anyway, we're already doing all of the work to track every update that happens across every part of everything in our system. I feel really, actually. And I got to look at all these things and go, what the fuck is your gem update doing? Every single time you guys push an update, and I love you guys, thank you for all the work and gems and everything. We're going to be contributing back too. So if I don't do this, you can tell me I'm a jackass. But anyway, I gotta look at all of your code and all these gems and all these updates and interpret from changelog messages, from commit tags, all of these things. You gotta do a diff on your commit so that I get the update and that I can justify it with our documentation, our legal team and all that stuff. So thank you so much to everybody who maintains a good commit log. It at least gives me a clue of where you're going with things and why this update makes sense. And I saw one update, I swear, it broke something actually. Well, something was broken. This one didn't cause it. Thank you. And I went through everything. It was a spelling update. I had to update all of our servers to update a gem that had a spelling fix. That was frustrating. We made a really drastic decision based on all of this chaos and just madness. It was a lot of fun, but it was absolute madness. We're not updating anything at all. We're not touching anything that's in production. Once it's in production, it's there. We're going to throw it away. We're going to rebuild from scratch. And this is where the Vagrant part of things actually comes in. With Vagrant, we all have the idea now. You can script a system, build it, and you've got a perfect state, and you go and you run with it. That's what we wanted for production. And that is not easy to do in production. It's especially not easy to do quickly and while rolling all of these updates together. So how do we do it? What problems we run into? First problem was all of our configuration files are in Git. They're all readable. If some Russian hacks GitHub, they have our passwords, you know? You gotta look at your app and say, okay, well, I got this Puppet file that has a password, and I set it as password. No, I'm good, that's fine. But where do you do that in production? Where do you put your configuration file for, you know, your SQL? Do you put it in the app config, or do you put it in Puppet? If you're a small team, and you trust everybody, and you're not having to deal with these crazy requirements, you might just put it in the app. That's totally fine. Totally understandable. We couldn't do this. There's too much risk on having that information exposed. So we wrote a tool that we're going to be releasing called CRYPTAR. And CRYPTAR is awesome. I love what it does. This was so much fun to build. And I went from knowing almost nothing about a lot of pieces of this to one night at like 3 a.m. just having an epiphany. And I wrote it and it was awesome. We hope it won't collapse under the weight of my craziness, but it will be awesome. CRYPTAR takes all of your configuration files, all your sensitive things, your certificates, all this stuff. It encrypts them, lets you put them into your Git, put them on GitHub, whatever. They're totally useless to anybody else. When your app boots up, when your server starts, you can do a really quick process to just decrypt that file and use it. You can do that within the app because we give you a gem, and you can do this on the service level because there's a really quick binary tool. So that's really simple and really awesome. In our case, it actually talks to our key server and does a whole bunch of wizardry just to make sure that we have the key and I don't even know, but it's pretty nuts. Another problem, we have to keep all of our gem versions in sync. We have 7 servers doing 7 different jobs. They all have to talk together. I have to review all of those. And so I want everything perfectly in sync as much as possible. If I'm using rack over here, I want the exact same version of rack over here. Because when I do an update, I gotta look at every diff between those. It's gotta stay straight. So we wrote a tool called GEMINATOR. GEMINATOR goes through all of your repos and all of your projects and looks at your gem files and then tells you where you are with all the versions of those things. Then it goes out, it pulls your updates into development. Now you have a state that's completely updated and you know what updated from where to where. That's awesome for documentation. But then you can also go through and look at the final report, which shows you, as a system, as a whole, what gems are you using? What versions of what gems are you using? So if you're using 2 versions of rack now all of a sudden, you can go back and see what conflicted on which service to give you 2 dependencies. And it's really easy to fix that. This process started with a totally manual process, and I was CDing through a directory and all this, and I'd do this over and over and over, and it took hours. We got this down to, we do this 2 days a week now. We celebrate Patch Tuesday and Patch Thursday to keep this particular element in sync. So, we've got our gems, we know where we are with those, we know our update path for those, everything's good. Now we gotta do the same thing for system updates. And as I said, we can't use landscape. It's way too expensive. It just would be crazy expensive, even though it's a really cool tool. And this is why as a SOA, we have to make decisions that kind of suck. You know, if you've got a server and an app and all this stuff, and you can take one server and replicate it out using somebody else's tool, if you can push to Heroku and do all that stuff and not have to worry about it, that's awesome. We're very jealous of that ability. So for us, we have to write all these tools. We have to keep all these updates in sync. We have to know where everything is. And so we wrote PATCHINATOR. I think you're noticing a theme with our names, and that theme is that we're not creative. We just go. Anyway, PATCHINATOR looks at all the systems, just like GEMINATOR does, and it tells you where the current patch level is. Then it does a little bit of external magic and scrapes dozens of sites to find all of the packages that are updated or that have updates available. Then it looks for all the CVEs, which are security bulletins, related to all of those patches. So once you have your state, the available updates, and the CVEs related to it, you can make a judgment call. And you can say, okay, everybody else is calling this a super high risk update. I better do the same. Or it's low risk, no big deal. In our case, we have a policy that says a high priority update gets installed within however many days. In reality, we are way ahead of that, and I'll show you why. But first, the segue, continuous integration. Where does that fit into this whole mess? Usually on your app, you'll deploy some code, and it's ready to merge, you're happy with it, run continuous integration, now you know it's safe in your test environment, and then you go ahead and deploy. That's good. We want that. We would love to have a hosted tool to do that. But how do you continuously integrate in a SOA where you have multiple versions of different services in production? You basically have to rebuild the entire continuous integration test platform every single time. You have to build it to be in sync with production so that you're testing all of the angles all of the time. It's pretty nuts, but we came up with a process to make this simpler, and we call it continuous buildation. With continuous buildation, we're taking the result of our continuous integration and we're rolling it forward. We're not just saying, okay, everything's good in test. Let's take that result and let's go ahead and push that into production. Let's go through our deploy process now that we know that worked. Between your test and production environments, a lot of crazy stuff can happen, and it just happens over time. As David was saying, sometimes somebody installs something on a production server and you don't know. Now, let's say you have to deploy and you don't know which version of Mongo has the right patch for the geo-indexing that you need for this specific app. I mean, these are little details. This happens all the time, especially in a traditional environment where you have a server that you're updating. So with continuous buildation, we know our test work, we know it worked, we know it's clean, we know it mirrors our production environment exactly, so we can take the result and just shove it directly into production. So we're always integrating all of the time, always building, always making new. We're never, ever touching a production system to apply an update, which is, that by itself is kind of crazy. We continuously build, we run this process every single time we apply a system update, we apply a gem update, we deploy some code and are ready to test it, when we touch a Puppet manifest, or when we change a firewall rule. All of these things add up to kind of some crazy stuff. So, okay, well, I'm going to skip this. This is how it basically works. We start with a clean, brand new Ubuntu image from Amazon. And we install all the security updates, we run our Puppet manifests, we get it all set up for production as far as the system is concerned. This is the longest part of any build process. When you're deploying, this takes forever, 30 minutes, an hour, whatever. You might have a build document, if you're lucky, and you just repeat the steps, and now you have to go curl these sources and do weird make files and whatever else. But this is done automatically for us as a stage one. We save that stage one AMI in Amazon on S3. We take it, we put our code on it. Once our code's on it, it goes through the whole continuous integration process. Now we know that we have a perfectly updated system. We know our code works, and we know that it mirrors our production exactly. So we can take these, save them as a stage 2 AMI, which has everything running, everything ready, and we can just make new instances off of that and just go. We can fire up a new instance, get it into a load balancer within seconds. The tool we use for this is called DEPLOYINATOR, and we'll be releasing this as well. And it does some other interesting things. It lets us tag instances, which is an interesting concept that some of the cloud providers are now going with. But the main idea is you have all of these instances, and you need to be able to identify certain behavior and certain parts of them. Usually we do this just by giving them machine names. And a lot of us get clever with machine names. Your mail server, you might have a naming scheme that's like superhero sidekicks, and you know that your mail server is called Robin. So you talk about logging into Robin to fix a problem. I mean, this is how we talk. We don't want to fall in love with the server. We don't want to call it by name. We don't want to acknowledge its existence once it's built, because that means you care about it too much. It means you're touching it. We don't ever want to touch it. We generate hash names for all of our servers. They're just completely anonymous. We can kill them and we don't feel bad about it. I'd feel bad if I killed Rob. So, we can go through the whole deployment process in about 10 minutes. We can roll through every one of our servers because we have this buildation scheme, and yeah. So let's say overnight, an SSL update comes out. All of these servers, every one of them except Windows guy, but we don't care about him. Every one of these servers is affected by that. In a normal world, you would log into each server, touch it, apply this update, and pray that you didn't break production. This is how the world works. You might do it through Puppet, but you're still hoping that your Puppet doesn't break production because of some other dependency that now you have to update your Puppet configs and all of this. If our Puppet configs change because of an SSL update, the continuous buildation process screams at us and says, no, I couldn't make a new one. And then we go fix our thing and it works and we're good. This happens for us because of DEPLOYINATOR and PATCHINATOR in this process automatically overnight. When we come in the morning, we get a nice little email that says, PATCHINATOR found these updates, DEPLOYINATOR went ahead and installed them, and we have new images for you right now. So then it's up to us. We can make the decision. We can say, yeah, I want to just go ahead and kill these 62 servers because now I have fresh instances. I'm going now. We don't have to talk about it. It just happens. So that's a really freeing thing, and I think that's where the disposability of all of this really shines and makes it worthwhile. There are a few weird things along the way with all of this. Hold on, sorry. The Amazon console isn't perfect. The API isn't perfect. They can be slow. Every Amazon outage that's happened has affected the control plane in some way. People panic and then they overload it, and now you're compounding the problem, and we all hate it when that happens. There are a few user interface issues with the console, overlays that won't go away, items that all of a sudden won't be clickable until you reload 50 times because some JavaScript down the line is whatever. So that's kind of annoying, but if you use the API, you don't have to worry about that as much. The REST API is really good, especially if you just want to dive in and just poke at things, start up a server, kill it, do some business. And once you kind of know where you're going with that, then you can write your scripts for it. Using the AWS SDK gem, you can do the exact same processes with the API, and it's actually really quick. You can write tests for it, but really it's just blow it away and do your thing. So once you have your scripts, wow, I repeated myself, that's stupid. Sometimes it takes multiple requests to get down the tree of information. The API is really granular, so you have to make multiple requests to get all of the information about all of your instances and whatever context you need for whatever report you're making. Sometimes that can really take a long time. There is a little tip that we learned after waiting and having timeouts and having to rescue things. The AWS SDK gem has a method called memoize block, and this is magic. It just basically memoizes those calls so you're not making them all the time. Definitely worth doing. Load balancers have some weird issues, specifically when they're cold and you start putting in things or rotating out. Sometimes it'll take forever, and sometimes you have to remove an instance and re-add it for it to actually take effect. That's just annoying, but it happens. So there are a few things you can do to just kind of get in this mode. A lot of this is crazy. A lot of the scaling concepts and things won't apply to anything and I probably just sound like a crazy ranter about this whole gem issue. But there are some really cool things happening with RubySec and some other projects that really want to help track reliable issues on Ruby gems and such. So I'm really glad those exist. And I think we all should be talking about security, because when we just gem install blindly, you're copying that person's code into your code, and you own it now. Benjamin Smith gave a really good talk at Ruby Australia, where he basically outlined how easy it would be for somebody to just put a gem out there that watches your app, something that does flash message, helpery, whatever. Put this gem out there, people start using it. Well, in the background, there's a little bit of obfuscated code where his code is watching your logs, and any passwords that go through are just automatically kicked to his server. That's a really easy example. That could happen. And if it does, we're all kind of screwed because nobody's reviewing these things. We might look at a commit if somebody says something really dumb, and we see it on Hacker News, and we go and we laugh, and it's fine. We might look at the code example. But we don't really go through everybody else's code, and I think that's kind of a problem. So, anyway, security aside, gem aside, all of that. You start thinking about your system as a disposable set of units. And just like with Vagrant, you can do the same thing with production. Use Vagrant to learn the process and get into Puppet and all of that. Get in the habit of that just because it's amazing. And then start writing your own automation scripts. GEMINATOR, PATCHINATOR, DEPLOYINATOR, they all came from us realizing that we were doing the same thing 17 times. So we wrote a very dirty script the first time, and you iterate over it, make it better, you start adding variables, you start learning more things, and pretty soon you actually have something valuable that you can release and give to people. Our build process is totally, I think, usable in any context, on any cloud server. Rackspace lets you make images and store them and launch from them. Amazon does the same thing. Everybody's basically doing this. If you build an image that you know works, launch that into production, you're good to go. Now launch one that you intend to update it, test it, redeploy, and now you can just swap those out. The Elastic Load Balancer, Elastic Beanstalk does this for you automatically. I wish we could use that too, but we can't. But anyway, so that's all of those things. Thanks for listening, and I do have 2.5 minutes if anybody has questions. Yes.
Here. Just out of curiosity, how big is your team with that many services?
How big is our team of humans?
Human beings, yes.
How big? Yep. Sorry. How big is our team of humans who manage all of this madness? It's actually a small team. We recently launched our product, and we're getting it into production and all that. There's 5 of us that manage all of this, and that's why it's so important to know and completely trust the Puppet and the process, because it could take a whole building full of people just to do the documentation that I do on a daily basis, well, every Tuesday, Thursday, to make sure the gems are updated. It's 2 pieces of paperwork for every gem that comes out for me. So don't just release gems just to piss me off. So, anyway, yeah, we are a small team. We're growing.
What would your advice be for an enterprise environment? When you have a cloud service and you can write your own brand new code, it's easy to throw things away in production. It's easy to say, I'm going to rebuild your stuff, but when you have crufty old code and developers who are doing who knows what in an enterprise environment.
Yeah, the question is how would we advise someone in a enterprise environment to use some of these elements of disposability and kind of use that mindset when you have stuff laying around that's old. That's tough. We actually face that in 2 other departments within our company. It's really tough. The best thing that you can do is start splitting those things out into services. And if it's a mindset thing, it's a battle you may win or may lose. I mean, that's a toss-up. That's completely irrelevant in my opinion. But as far as the technical things go, you can split things into services. You can host things separately to make sure that the thing that actually does the business is disposable. Whenever you're blowing away state to run tests, for example, you're throwing away bits of information that are out there and all this. You're redeploying. Well, the steps between testing and redeploying are just a matter of state. So if you can keep that state somewhere else, then you can redeploy and throw away and it's fine. You know, and I don't do a lot of that kind of enterprisey things. We're really lucky to have the team, the project, and all the things that we have just to make this possible. So I appreciate that. Yes.
With most gems being MIT or BSD, can't you just fork the gems and sidestep the PCI requirement?
Question is, couldn't we just fork most of the gems and not use their updates directly to kind of sidestep the API, PCI burden? Yes, we totally could, and we talked about that. And I wasn't comfortable with that, mostly because if they're doing an update, I gotta assume they have a reason, and if we're not really subscribing to all those things and paying attention to the reasons why they're doing those, we're gonna be left behind, we're gonna get hacked. I mean, we have to stay up on everything. That's at the core of everything we do. Maintaining that is key. So we totally could. There's a lot of ways we could just kind of sidestep the process and legitimately do that as far as the paperwork goes. But if we have a bad day, they're going to come back and say, well, you did this. That's stupid. So.
Well, I'm asking that as more, at least you can manage when you do those upgrades. The gem update isn't going to be the thing that pushes you to upgrade.
Do it. So the follow-up to that was we could basically fork those, pull those in a scheduled way, and then manage all of that in groups, in batches, in staged kind of schedules. That's absolutely reasonable. That's not wrong at all. By doing it twice a week, we gain some momentum, I think. We do take on all that burden, but I feel like if we put it off at all, even a week, you know, if we waited a week to do all of this, it's just going to be harder. So we really try to do it all at once. So I'm out of time, but we're going to be around, so I'd love to talk about this if you guys come up to me.
So we asked on our CFP for a video submission. It was like, oh, you know what, maybe just say, oh, I'm really passionate about this idea. That would be a good way that we can see how much you really want to talk about that. We're like, okay. And so this was one of the videos we received.
Hi, I'm Bryan Thompson from Hansburg, and I'd like to come speak at Ruby Midwest 2013. Hansburg is a payment gateway featuring RESTful API and developer-friendly libraries. We've built a suite of integrations including JavaScript encryption, tokenization, transparent redirect, and our own badass hosting forms. I'd like to talk to you guys about our service-oriented architecture and some of the things we learned about hosting our system on Amazon along the way. I've gotten rid of my old